lecture we will discuss about the continuous reactor. Continuous reactors. The continuous reactor or CSTR, continuous stir tank reactor, the PBR, PFR, these are continuous reactor. Pack bed reactor, plug flow reactors. These are the three types. There are many types of continuous reactor. In this lecture we will discuss about the continuous stir tank reactor. Now the continuous stir tank reactor, which is CSTR, usually it is used in the liquid phase reaction. In the liquid phase reaction. It is used in liquid phase reaction. It is used for large scale production. Large scale production, and it is continuous. It is continuous reactor. As we know, I have already discussed that batch reactor is used for small scale, but this reactor is used for large scale production. So now we will write the mole balance for the CSTR. As we have already know that the general mole balance equation is input minus output plus generation is equal to accumulation. Now in case of component A, it can be written as FA0 minus FA plus RA into dV is equal to change in the mole of A per unit time. Now there is the CSTR. Suppose this is the CSTR reactor. The fluid come in to the reactor and the product form and it leave the reactor, and the flow rate of fluid here is FA0, and this is the volume of the reactor, and the fluid leaving the reactor or the product leaving the reactor is FA, and this is the volume of the reactor, and it run continuously, and it run at steady state. At steady state means that there is no change in the mole in the reactor with respect to time. At steady state this term will be 0. So we will write this relation, and there is one assumption. There is also another assumption that here there is no special variation in the rate of reactant in the CSTR. Like in batch reactor the R was constant. Similarly in the CSTR there is no special variation of the reaction parameter, like the temperature is constant everywhere in the reactor, the concentration is constant everywhere in the reactor, and the rate is also constant everywhere in the reactor. So in this concentration, this time or this temperature, the temperature or the rate which is present in the reactor is equal to the outlet concentration, outlet rate. So the rate inside the reactor is considered is equal to the rate of the exit flow rate in the case of CSTR. So rate is constant in the case of CSTR. So this term is 0 for steady state process. Now what will be the mole balance for component A, which is FA0 minus FA plus generation is equal to accumulation of A. At steady state this term is 0. Now this is constant, so FA naught minus FA plus RA, and there is only volume, which is this volume, so this term is equal to 0. Now we can also rearrange this. RA is equal to FA minus FA naught divide, so we can also write the volume of CSTR as FA minus FA naught divided by rate of A, and this rate of A is the exit rate of we consider the exit rate of A, and the exit rate is nothing but it is equal to the rate which is present in the CSTR. So this is all about this CSTR. We can find the volume of the CSTR when we from FA naught and the rate of the reaction. Similarly, the rate of reaction can also be found from this equation A. As we know from the previous equation that FA minus FA naught divided by RA is equal to volume of the CSTR. Now we know that flow rate of A is equal to the product of the concentration of A into the volumetric flow rate of A. Now we put this equation in this, we can put this equation in this equation, so it can be written as CA into volumetric flow rate of A minus CA naught into the volumetric flow rate of A in the inlet, like if A naught is equal to CA naught into V. So this is the rate of A, this is the exit rate of reactant A, and which is equal to the volume of the CSTR. Now if V is equal to V naught, the exit volumetric and the inlet volumetric flow rate if equal, then this term will be CA into volumetric flow rate minus CA naught volumetric flow rate divided by rate, and volume by volumetric flow rate is nothing, volume of the reactor divided by volumetric flow rate is nothing but the space time of the reactor. So it is equal to the space time is equal to CA minus CA naught divided by RA, and this RA is the exit rate, this is the exit rate